Hey guys, today I'm going to show you how to answer the question that says determine the values of x whereby the graph is concave downwards or upwards. So guys, you just need to expect any between the two. Sometimes the examiner will just say determine the values of x whereby the graph is concave upwards instead of downwards. So you just need to familiarize yourself with those such questions. Okay, before we proceed, just click on the subscription button so that you can be able to you can be able to get the notification whenever I upload a video, right? So before we waste any time, let's focus on the question and solve. Okay, in order for you to answer this question correct, you just need to find the point of inflection. There's a point called point of inflection. So that is the midpoint of the graph of a cubic function, of any cubic function. That point is called a point of inflection, not a cubic function because it is a cubic function. So that point is called a point of inflection. So on the point of inflection, we have two coordinates, but our focus is going to be on the x coordinate of the point of inflection, right? So let's derive this equation twice, because in order for you to find the point of inflection, you just need to derive this equation, the original equation of the cubic function, twice. Then after deriving it twice, you can just equate your equation, that second derivative equation, to 0. Then solve for x, because that x coordinate of the point of inflection, it is the master point that can allow you to answer this question, or let me say that is the master point that can allow you to conclude that this portion of the graph is concave downwards and this one is concave upwards. Okay, let's go for it, guys. So we have our original equation. This is our original equation of the cubic function, which is f of x equal to x cubed minus 3x squared minus x then plus 3. Then we have our original equation of the cubic function. Now let's derive. So we have our first prime. This is our first prime. This one line symbolizes what? The first prime. Let me say this whole thing symbolizes the first prime. But this one line symbolizes the first prime. So equal to what? 3 multiplied by the coefficient, which is 1. So 3 multiplied by 1 is 3. Then x, then subtract 1 from this exponent. 3 minus 1 is equal to 2. Then 2 multiplied by minus 3 is minus 6. Then put your x, subtract 1 from this exponent. 2 minus 1 is equal to 1. So we have invisible 1. Then 1 multiplied by minus 1 is minus 1. Then subtract 1. 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. So here we have our 1. So this is just a constant. So whenever you derive, you just need to make it a point. Just need to know that a constant will always become 0. It automatically becomes 0 whenever you derive. Whenever you derive any equation, your constant is going to become 0. Right? So, okay, what is a constant? A constant is a number that can be able to stand by itself. Like for instance, this 3 is not attached to any x. But what about positive 1? Positive 1 is attached to x cubed. What about minus 3? Minus 3 is attached to x squared. What about minus 1? Or minus 1 is attached to x. So those are not the constants. So our constant is positive 3 because it's not attached to any x. Right? So what about, where is the constant on this equation? Our constant is minus 1 because minus 1 is not attached to any x. But minus 6 is attached to x, and also this positive 3 is attached to x squared. So now let's go for our second prime. So this is our second prime. As you can see, we have two lines, then we have our x, right? So this is our second prime. So 2 multiplied by 3 is equal to 6. Then you put your x, subtract 1 from this 2. 2 minus 1 is equal to invisible 1. So we have 1 multiplied by minus 6 is minus 6. Then 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. Right? So meaning that we are going to be left with minus 6. What about this one? Whenever you derive, a constant is going to automatically becomes 0. So we are going to ignore that. Basically, we are not ignoring it. This minus 1 is not being ignored, but it has transformed itself to become 0. It automatically becomes 0. So let's now equate our equation, which is the second prime equation, to 0, so that you can be able to solve for x and find the point of inflection. So we have our transpose Then we have 6x divided by 6 both sides. Then our x is equal to 1. So this is a point of inflection, x coordinate of the point of inflection. Then in order for you to find the value of y, you just need to plug this one to your original equation. But there is no need of finding there is no need of finding the y value, because the main objective here is not to find the point of inflection, but the main objective here is to answer the question that says determine the concavity of the graph, whether the graph is concave, determine the values of x whereby your graph. Basically the question here, the main objective here is to answer the question that says determine the values of x whereby the graph is concave downwards and upwards. So x coordinates of the point of inflection, it is the only coordinate that is going to allow us to find that to determine those points, or let me say to determine those determine those portions of the graph whereby our graph is concave downwards or upwards. So let's go for it, guys. Let me construct our graph. So let me construct our graph. So this is our Cartesian plane. This is our Cartesian plane. We have our x-axis and also our y-axis. Okay, before we construct our graph, okay, the only thing that is going to allow you to construct the graph of the cubic function is the value of a, because a determines the shape of the graph, whether is it an increasing function or a decreasing function. Okay, let me say to you guys, let me explain this. If the value of a is greater than 0, positive 1, or let me not say positive 1, any number, even half, because half is less than 1, so even half qualifies to make this equation to half x cube qualifies this equation to become an increasing function. So whenever the value of a is greater than 0, this equation will always be called an increasing function. So this is our increasing function. This is the shape of the increasing function of a cubic function. So it's going to start by increasing, going upwards before it can decrease. So this is the shape of our graph for this equation. But if the value of a was less than 0, meaning negative, maybe let's say minus half or minus 2 or minus 1 x cube, then our equation, our graph was going to decrease before it can increase. So this was going to be the shape of the graph. So we have concluded that this graph is like the value of a for this graph is greater than 0, meaning that our graph is going to start by increasing before it can decrease. So this is going to be the shape of the graph. Now we have said, guys, the point of inflection is the midpoint of the graph. So this is our midpoint of the graph. Now we are going to answer our question. Now x equal to 1. I've said to you, it doesn't matter whether if we have managed to get the value of y, but for the sake of finding the actual value of the point of inflection, we can just plug our 1 to our original equation so that we can be able to find the actual point of inflection. So let's find our actual point of inflection so that we can properly construct our graph. Okay, but we can just answer this question without finding the value of y, because in order for you to answer this question, you just need to find you are going to only use the x coordinate of that point of inflection. So find the value of y is just a waste of time. It's just a waste of time. So let's determine the values of what? Let's determine the values of x whereby our graph is concave downwards and also upwards. Okay. Upwards, what is the cone? Okay, this concave, it's made up of two ways. This cone, we have a cone and also a curve. 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 We have a cone and also a curve, right? So when something is a cone, okay, we have different types of cones. We use cones to contain a cone. It's something that can be able to. It's a container. A cone is a container, something they can be able to contain, right? So this is the shape of the cone. Right? A cone is something that can be able to contain. we have different types of cones. We use cones to contain an ice cream. Sometimes we use cones. Cones have been used by traffic coppers. So, but I'm not there. I'm trying to say, guys, a cone is something they can be able to contain. So a cone can sometimes be in this form. You can be able to hold it like this. Sometimes you can be able to hold it like this. So it's up to you. The choice is yours to make when it comes to holding a cone. So, okay, which means this wave is made up of what? Of two waves. It's a cone and a curve. So in order for you to answer this question that says you have to determine the values of x whereby your graph is concaved downwards. Okay, let's check. Okay, our graph is made up of two cones. From this point of this midpoint of the graph, from this point all the way to this side, we have a cone because we have something that is like this. So we have a cone, right? So our cone here is cone, like this portion is concave, it's a curve. A curve is something that curves, right? When something is curving, you know. So here we have a cone. It's like we have a cone, right? This cone is concaved, like it's curved downwards. So meaning that this side we have downwards curve. We have downwards, the curve that has pointed downwards. The curve, this is a curve that has pointed downwards. As you can see that we have an arrow here, so this arrow has pointed downwards. So meaning that we have a downwards curve. Our graph is concaved downwards from this portion to the negative infinity, from this portion to the negative infinity, right? Meaning that our graph is concaved downwards whereby the values of x, our graph is concaved downwards whereby the values of x are less than 1, whereby the values of x are less than 1. From this portion all the way to negative infinity, our graph is concaved downwards. But when it comes upwards, from this portion to positive infinity, our graph is concaved upwards. Meaning that our graph is concaved upwards. From on this portion our graph, as you can see, guys, this is a cone, but this cone has curved upwards. So we have a cone that has curved upwards. So our curve is concaved upwards, meaning that here we have 1, but here 2, and also 3. Maybe somewhere here we have 3. So those values from this one, and also from this one to positive infinity, from 1 to, because 2 is greater than what? Is greater than 1. So our graph is concaved upwards whereby the values of x are greater than what? Whereby the values of x are, okay, basically this belongs here, whereby the values of x are less than 1. So this graph is concave downwards whereby the values of x are less than 1. But it's also concaved upwards whereby the values of x are greater than 1. Whereby the values of x are greater than what? Whereby the values of x are greater than 1. From this portion all the way to positive infinity, our graph is concaved upwards. So guys, without wasting time, okay, let me say it to you guys, just drop any topic that you're struggling with when it comes to maths on the comment section so that I can be able to make a video and help you out. So don't forget to subscribe on my YouTube channel so that you can be able to get the notification whenever I upload a video, because this thing is all about collaboration from me to you, from you to me. Guys, that's how it works when it comes to the concavity of the graph.